In this video, we're going to look at charts and how they can provide information and make information more understandable. But we're also going to look more interestingly at how charts can obscure information or perhaps even lie a little bit. So charts can help the audience understand data that you're presenting. And sometimes a chart can provide insights that might have been missed just by observing the raw data itself. But it's important not to put charts together just for the sake of it. Charts can look very attractive, they can look very impressive, you can now get some lovely 3D effects, so they can add some whiz, bang and wallop to a presentation. But if they're not really providing information or illuminating anything, then they're actually just a waste of time. So charts must make a point. So when you are putting a chart in a presentation, it's not just a matter of presenting data. You must be mindful of what story the data is trying to tell and how the chart can illuminate that story. Significantly, charts can sometimes deceive, and that's something we're going to look at. So charts and diagrams and graphics and visualizations and maps, these can all provide insights that might otherwise not be possible. They might not be immediately obvious. Perhaps the most famous graphic ever in information design is a map by Dr. John Snow from 1854. And he took a street map of London and he put markers to identify the location of people who had contracted cholera. And by visualizing the information geographically, he was able to identify that the Broad Street water pump was a factor in people contracting cholera. Now, at this time, people had no understanding of microbiology. They had no understanding of bacteria or viruses or anything like that. But he could see, based on this visualization, that there was a connection between this pump and the disease. And so he actually got the handle of the pump removed and the cases of cholera dropped significantly. This chart and this visualization is so important that it's kind of almost taken on a life of its own. Actually, there's a whole story of the chart as well, and it's become quite celebrated and has been redrawn and is often cited as an example. So the main purpose of charts is that they can help the audience understand the point that you're making and understand the raw data. That's not to say that tables aren't useful. Very often a table is the most useful way of presenting the data that you have. But if there are trends or relationships or other points that you want to make that might not be easily visible from the data, a chart might be useful. So here we can see, for example, in this chart that marketing costs are increasing quite significantly year on year, while all other costs are, stable-ish or even going down to some extent. But looking at this chart, it's clear that marketing budget and marketing expenditure is going up and up and up. So there's a trend there, and that's the point of this chart. It's important, however, to choose the right kind of chart. So Excel and other spreadsheets can provide lots of different kinds of charts. And some people just select the data, then select a chart, and then decide what looks the prettiest, But we can see that this chart here, which is just a bar chart, is, all the information is there, all the data is there, but it doesn't tell the same story as the line does. here lines are the most appropriate way to tell the story that this data is trying to tell. This isn't so useful. This chart here is not only less useful, it's actually, quite useless, because some of the information is just missing altogether. We can't even see the manufacturing information because it's obscured behind all of the engineering data. So some data is completely missing from this. No, it looks pretty, but it doesn't do its job at all. Here is a scatter plot, which is totally meaningless. The information here is just pointless. It reveals nothing. Here we have a mixed chart, which, there may be scenarios in which that's useful, but for the information we're looking at here, it's not useful at all. It doesn't really help. It just confuses things. So it's important to consider the right kind of chart to tell the story that the data is trying to tell, or that you are trying to tell with the data. This one here looks gorgeous. All these very impressive, three-dimensional bars. Look at those gorgeous shadows there, the shading on the bars. Gorgeous, but completely pointless. It doesn't illustrate the data at all. In fact, it has the pretense of trying to provide all of the information, but you can't really see there what's going on. You could probably figure out that marketing is going up all right, but the information is obscured here really. It's not as useful. Looks gorgeous. Which brings me then to the next very interesting section, I think, is how charts can actually lie. So there's two quite celebrated books, How to Lie with Charts and How Charts Lie, and another one related, which is How to Lie with Maps. We're not going to look at maps, but it's interesting to see how even when you are presenting the information factually and presenting the raw data, there are tricks people use on purpose or mistakes they make by accident that can result in charts that actually deceive the viewer while purporting to illuminate or to provide factual data. So this first example here is a real example, and this was from a Government of Ireland report from 2009, Delivering the Smart Economy. And so there are actually three pieces of information here, I suppose, for each year. There is the business expenditure on R&D by Indigenous-owned companies, business expenditure on R&D by foreign-owned companies, and then the total overall. And we can see that both of these values, because the third is just a sum of the other two, both of these values are increasing year on year. But this chart is actually quite deceptive visually, okay? So if we look here, the bar representing the expenditure by Indigenous-owned companies is actually in front of the bar representing the foreign-owned companies' expenditure. And that little drop shadow there, just underneath the dark blue bar, is supposed to give us a clue that one is in front of the other. So that's, I suppose, the designer's get out there, his saying, look, I did a drop shadow there that shows you one is in front of the other. So these aren't stacked, they're layered from front to back. Okay, so some of the data then, some of the bar for the foreign-owned expenditure is actually hidden behind the Indigenous-owned expenditure. So some of the brown bar there is actually hiding behind the dark blue bar. We just can't see it. And then the total then is shown by adding the value on the bottom back on, so we can see what the total value is. So it's no surprise then that the light blue bar on top and the dark blue bar on the bottom are exactly the same height. And anytime there's data being repeated in a chart, it's probably a hint, that there's some shenanigans. So this has the effect then of making the foreign-owned expenditure look a little bit more than the indigenous-owned expenditure. But of course, it's actually more than double. It's just visually, the dark blue and the brown, the brown isn't too far off the dark blue. But of course, almost half of it is hidden behind the dark blue bar. So a more honest map would look like this, where the foreign expenditure is in light green and the indigenous is in dark green, and then you can see more clearly the relationship between them. And it's clear that the foreign-owned expenditure in R&D is easily double the indigenous every year. So this is a more honest chart than this one. Now, if you look at the fine print, if you analyze the chart in more detail, you can see what it's saying, and it's not lying. But if you're skimming past, it does create the impression that sure, the foreign owned is greater than the indigenous, but not by much. Whereas in fact, it's more than double. Now, another way a chart can deceive is by tweaking with the axes and showing only some of the data. So here, this man started work in Q1, and he's saying, look, sales have increased since I joined the company. And indeed they have. Sales have increased quarter on quarter ever since he started. But maybe this isn't telling the whole story. If we look at what happens before he started, we can see that sales were really, really skyrocketing. This company was on a roar. And then at this point here, when he started, sure, they continued to increase, but the rate of increase was drastically reduced. So here, it's like this guy's doing great. Things have really improved since he joined. Give that man a raise. But looking at this data here, it's like, oh my God, what happened? We were doing great, and now we're not. So seeing the data in context tells a completely different story. And these are both showing the same information, the same numbers are visible. But this chart here isn't telling the full story. Whereas I think it's clear that this one does. And of course, each of these charts tells a very different tale with the same data. Here again, we can see that adjusting the axis can distort the data. So here we're looking at annual profits year on year. But here the designer of this chart has gotten up to a bit of jiggery-pokery by starting the axis below zero. So in 2019, the company had losses. But here, at a glance, they look like low profits. A more honest chart would display this information without resorting to negative values on the axis that look positive, but would do something like this. So here it's clear that in 2019 the profits were negative and they were losses. And the only difference between these is that the axis has been altered and that the negative value is shown correctly as a negative rather than a positive from a very, very low base. Here again, we can see that adjusting the axis can distort the data. So here we have our annual sales from 2017 to 2022, and it's clear that 2020 was a bad year. Looking like quite a bad year, really, relative to the others. But if you look here on the left, we can see that the data starts at 480 million and goes up to 520 million. And if we were to show the complete axis, we can see that, well, in context, that dip is still a dip. But in the context of the overall sales, it's not such big a deal. So here, 2020 is a disaster. Here, 2020 is, a bit of a dip. So in both cases, it's the same data, but they're telling quite different stories in each of the slides. Now, packages for generating charts can produce some lovely, gorgeous effects with three-dimensional shapes and drop shadows and shading and all sorts of wonderful things. And they look gorgeous. But we have to be careful that we don't distort the data when we use these tools. Although a lot of the time, I think when we see examples of these, the designer knew exactly what he or she was doing and chose to distort the data slightly. So a pie chart is very useful for showing proportions of a whole. So here we're showing that production costs have 25% accounted for by labour, and then the rest is other things. So of the total cost of production, 25% of that is labour. And here we have a pie chart that shows that quite clearly. Here we have a gorgeous 3D pie that has lovely shading. It's a three-dimensional pie chart, lovely shading and everything, and we can see the light there coming from the right. It looks lovely. But here the labour cost has been distorted because, as we all know, things that are far away are smaller. So the small cow is small because it's far away. And here, the labour cost is far away. So although this angle is still a right angle, it's still a quarter of the pie. And if you look closely, you can see it is a quarter of the pie. But just looks a bit smaller because it's further away. Whereas if the labour costs were up front here, again, this is only a quarter of the pie. It's exactly a quarter, exactly 25%. But here it looks much more significant than it does here with 25%. When the 25% is at the back, it looks smaller. So if we look at these side by side, each of these charts is allegedly displaying the exact same data. But clearly when the blue chunk is at the front of the image, it takes up more space visually, like just more of the pixels on the screen are taken up with the blue than are with the green. And so this is quite deceptive, really, I think. But you can see there's a massive difference between the one on the left and the one on the right. Even though it's just a plain vanilla pie chart, showing a quarter of the pie being used. But the visual effect is very, very different in each case. Now, the chart style can also hide data, so we have to be careful that we're not obscuring some information. So here in this line, it's very clear, I think, that the marketing budget is getting out of hand, really. Especially relative to the other costs, which seem to be stable or are on the way down for the most part. So looking at this, I would say, really marketing needs to ease off there now on the spending. If we present the same information in a different chart, so here it's a stacked line or stacked area, the exact same information is presented here, but you can see how the marketing budget doesn't seem to be quite so extravagant. So we can see that overall costs seem to be going down. It looks here as if the manufacturing cost, went up a little bit and now it's starting to decline, when actually the manufacturing cost is constant. But I think here, if you were in the marketing department and you were worried that your budget was going to be cut, you might prefer to present this slide at a meeting instead of this slide here. Because in the line chart, it's very clear that marketing is getting out of hand. Here, the exact same data is being presented. But, it doesn't look so bad. I mean, it even looks, you might even be able to convince yourself, because the top line there of the marketing area is actually going down. You might even sort of, for a moment, think, does that mean marketing is going down? Because both lines, both above and below the marketing area, are on the way down. Of course, the area is increasing drastically, but the line is pointing downwards. So, there's a trick of the mind there that, you kind of two clues telling you different things. And of course, in actual fact, marketing is gone bananas. We can even do this and then do the old perspective trick as well, and really throw in that in the mix too, and really obscure what's going on. So now we have the perspective at play here as well, so the marketing budget doesn't look as bad. Or we can do something like this even, which doesn't really reveal what's going on. Looks nice, distracting. This is a very impressive slide here, lovely graphics, lovely drop shadows, very nice. It's not revealing the data, which of course would be the point in this case. Now, a very, very serious mistake that people make, and I think this is one of the things that's often perhaps a mistake rather than a deliberate plot to deceive. But if a two-dimensional shape is being used to represent a one-dimensional value or a one-dimensional increase in a value, then the changes in the value should be represented only in one dimension. And I'll show you here what I mean. So it's important to realize that a 6 by 6 inch cake is not twice as much cake as a 3 by 3 cake. It's 4 times as much. And similarly, a 12-inch pizza is not twice as much pizza as a 6-inch pizza. It's way, way more. So you have to be careful. So this is a real-world example from the World Intellectual Property Organization in Geneva. And in this infographic here, they wanted to talk about how the number of domain name cases for its dispute resolution procedure increased from 2015 to 2016. And so the total number of cases was up 10%, and the number of cases from France was up 38%. But here, the year-on-year increase has been applied to both the height and the width of the squares. And that's very deceptive, because this shaded area here on the French graphic, that's actually 91% extra over and above the area of the square representing 2015. That's not a 38% increase. That's a 91% increase. That's very, very deceptive. Because what's happened here is that the designer has increased the height by 38% and the width by 38%. But that's actually doubling up on the increase. And then some. So this is very deceptive. So this here is what the graphics would look like if they were increased only in one dimension. And this is a more honest representation. Here, this is from the previous thing we saw earlier. The area representing the 2008 expenditure is actually about between 20 and 40 times the 1996 expenditure. And that's because not only has a circle been used instead of a rectangle being increased in one dimension. But actually, even if we look at the 1996 value, half of the circle is even obscured, whereas for the 2008 value, most of the circle is visible. So it's actually a massive, massive difference, when in reality it's actually less than 5 times. But looking at this, you would not think that the 1996 expenditure was slightly less than 5 times the 2008 expenditure, because visually in the graphic it looks somewhere between 20 and 40 times bigger. So that's very, very deceptive. So this chart here would be a more honest representation of that. Another issue then is when we go, instead of using 1 dimension, we use 2 dimensions. We can really push the boat out and go 3 dimensions, which makes things even worse again. So here in this stacked bar chart, we can see that manufacturing, research and marketing are roughly equal in the expenditure. If we use then a 3-dimensional cone to represent this, clearly here the heights are the same, but of course the volumes are completely different. So here we're not only using 2 dimensions instead of 1, we're actually using 3 dimensions instead of 1 here to represent the values, and of course this is completely deceptive. So when we are designing charts, we must make sure that they tell a story, they convey some information that isn't immediately apparent from the data itself. But we must also make sure then that the story that we're trying to tell is an honest one. Unless, of course, we are, I guess, trying to be dishonest. But the chances of us being caught out would be quite high. So it's important to realize that the choices we make can illuminate the data and can tell a story. But we must be careful that we're telling the correct story.